I'm gonna have to take it off the screen for a second. Sorry. So 17 is just like 16, but it's jujubes, okay? So I just, below, you can't see it now. 17 is just like 16, but jujubes.
Basically, to get 10 boxes, you plug in 25 that function.
You're not thinking about it quite right. You're not thinking about it quite right. Okay, how did this go for the range for whoppers? These are the numbers. So here's our range that's plus or minus 1 standard deviation. And then there's our plus or minus 2 range, 24 to 30. Everyone should have been able to do this. That's plus or minus 3. Your picture may look slightly different, but the numbers are what count. Is this what you got for these? Everyone should have gotten that. You add 1 standard deviation above and below. You add 2 standard deviations above and below. It should be 1.5 times 2. And then 1.5 times 3. You add it to 27, subtract it from 27. Any questions on that? Okay, so we won't do 15. So what did you find for 15A? If a box candy had 21 pieces, it's most likely in what type of candy is it? You should have found those junior mints. Junior mints. Okay? Because that would more likely reach down to 21 than whoppers would. So certainly it's not jujubes. There's way more than 21. It's going to be one of these two. So reaching down and having a likely data point at 21 is much more likely with the junior mints than the whoppers, because the junior mints has a greater variability, and they'll be more spread out, so you more likely get a junior mints at 21. So what about whoppers? That's even outside of the 3 standard deviation range. Very unlikely that you have. It could be, but it'd be an outlier, right? Whoppers box with 21 candies would be an outlier. Okay, so what about 34 pieces? What did you find? So for 34 pieces, now these two come into play. Which is most likely 34 pieces? What'd you find? Junior mints again. Because now these have the same standard deviation, and 34 is closer to 28 than it is to 44. So 34 is 6 away from 28, but 10 away from 44. So again, junior mints for both of those. All right, now if we want to create our sample, let's do our sample of 10 boxes of Whoppers. Did anyone think they came up with a good sample of 10? And so can you tell me, what was your reasoning? How did you think about it before you started?
Well, I stayed between the initial standard deviation.
The first range?
Yeah, the first range to the last range.
Okay.
And then I repeated 27 twice because it was a mean.
Okay.
And I just filled in numbers between.
But how did you fill it in? So what was your reasoning for filling in where the data points go?
Well, since the standard deviation was 1.5, I kind of just did it like every 1 or 2.
Okay. All right. So you just put them out this way. Okay. So what did we talk about on Friday that would help us? Yeah.
We just figured out that the first standard deviation is about 68%.
Right.
First time we went to 70.
So how you did what?
We instead of doing 68, we rounded up to 70 since it only had
Okay.
and we just put 7 within the first range.
That's what I was hoping you would think about. Okay. So in the first range, typically, how much percent of the data falls in there? He said 68%. So how many boxes would that be about in a 10-box sample? About 7 of them. So he's saying we're looking for about 7 boxes to fall in this first range because that would be about 68% of the data. Remember that? So go count how many of your boxes fell in the first range. Take a look. 4, yeah. So typically it'd be more. It would be more like 7 or 8, 6 or 7 or 8. So what was your list? Yeah. So what did you?
We ended up actually doing 6.
6. Okay.
We did 26, 26, 27, 27.
All right.
28.
26, 26, and then
2 27s.
2 27s.
2 28s.
Oh, I guess I'm let's try that again. Okay. So here's 26s down here. 2 26s, 2 27s, and 2 28s.
And then since there were only 4 left, we just did 1 within each, or 2 for the next standard deviation.
Sure.
For the last one.
So what'd you do?
We did 25 and 29.
25, 29,
And then we did 23 and 31.
23. Okay, so let's talk about that. So what percent of the data was in general falls for 2 standard deviations? 95. So in a sample of 10, what is 95% in a sample of 10? 9 or 10, right? 9 or 10. And then what was our percentage for 3 standard deviations? 99%. Right? So how'd they do? So what percent do they have within 2 standard deviations of the mean? They did 80, okay? Little low, all right? So maybe if there's a way that we could get one of those in closer and just have one outside 2 standard deviations, or even, remember, so 95%, that's like 9 or 10, right? So we could even have all 10 within the first 2. And that's really close to 95% of the data, okay? So there's different possible answers, but it's not wrong. It's possible, but this is pretty unlikely that you'd only have 80% or 8 boxes within 2. So did you crank out the numbers for this?
Yeah, we ended up getting exactly until I just stopped.
But did you get the standard deviation?
I
You didn't have a way to calculate it. Okay, so let's make a guess. What they did, would you guess that it was had the standard deviation that's a little bit too high or a little bit too low? Yeah, because it's probably a little more spread out than a standard deviation of 1.5, just because we have these 2 out here. that are outside that second range. So, but let's go ahead and that's our prediction. Let's do it. Where can I get stat lab here? That. There we go. Okay. So let's put in what they did and see what happens. 27, 27, 26, 26, 28, 28. Out of order, no big deal. We said 23 and 31. No, I forgot the 25 and 29 and 23 and 31. Did I get it right? All right, let's see how we did. So we're going to go stat, summary stats, columns, variable 1. Here we go. Let's see how it, so we got a mean of 27, standard deviation 2.21. Okay? Great first attempt. This is, I mean, they used a lot of good reasoning to come up with this. Okay? You got 6 in there. So how was it compared to what we wanted? Standard deviation was?
We did the first 2 standard deviations and we got 1.49.
Okay, so what was your, so did you have something similar to his?
Yeah, but we did in the range of 25 to 29.
Okay. So how can we change their data set? What should we do to their data set to get a better standard deviation? What should we do?
We'll add 128 instead of the 31.
Okay.
And then 229s instead of the 23 and the 25. We got 225s, 226s, and 227, and 228s, and 229s.
So you just went 2, 2, 2, 2, 2. So change this 31 to a 29 and that 23 to a 25. Try that. So the 31, we're going to change it to a 29. Let's see, do those automatically update? Oh no, you got to redo it. 23 to 25. Okay, I'll run it again. Standard deviation now is 1.49. So all we did was just made that data a little bit crunched more together by pulling those outside ones in. So we pulled this one. So we pulled this one in here, took that one and pulled it and made it 25, and pulled this one 31, made it 29, and then we got it. I mean, that's really close. I mean, you wouldn't have to go any further than that. All right, so you get the gist of that. So you really have to know what the mean is. You really have to know how the standard deviation works to do this exercise to make just to make up a data set that has the standard deviation and mean that's given. Any questions on that? So you should practice number 7, practice with jujubes, okay? Like tonight, and you got kind of a question like this for Wednesday's quiz. But practice with jujubes. And the great thing is you can just, there's nothing, you can just guess and then use StatCrunch and see how you did. And then revise your attempt. So there's no, you don't have to be afraid of being wrong, right? Because it's all about kind of estimating anyway. And you just try something and crunch the data that you made up, see how it matches to what you were going for. Make sense? Okay, so I did post the quiz. I've been talking about it. I posted the quiz for Wednesday. So you have it. So study. Get it out. Work through it. Ask me questions if you need to. I'm not going to tell you the answers. I'll give you a nudge. I'll give you a hint. But work through it before the quiz. I mean, you have the quiz. So everyone should get 90 or better. Questions on this sheet, this worksheet? Anybody have a question?
Are you going to post this sheet on Blackboard?
What sheet? Well, it'll be in the video, but I can if you just remind me. So, but for sure, you'll just open up the video and it'll be the whole first 10 or 15 minutes of the video. It'll be sitting there, so you can find it that way too. But if you email me, I'll post it, the actual document. Other questions? Okay, so we're going to move on to the next section. So we looked at different measures of center, and then when we talked about the standard deviation, so we got the mean, median, and mode. So the standard deviation then is associated with which measure of center? So the standard deviation is associated with which measure of center? We've just worked. Right, we made these ranges based on the mean, right? So standard deviation and the mean are like a pair, right? They're like cousins. If you're dealing with the mean, then your measure of variability will be the standard deviation. If you're working with the median, what we have is what's called the 5-number summary or box plots. All right, so this is the associated way of looking at variability if you're focusing on the median. So let's look at this. This is another way to kind of get a feel for how spread out the data is. But this one's more based on the median rather than the mean. Okay, so it's quartiles. So we talked about the median is the middle value. So then what you do is you take then the upper half of the data above the median and you find the median of that. That's called the first quartile. So we're breaking, for the median breaks up the data set, 50% of the data is below, 50% of the data is above. So you take that 50% of the data that's below the median and you find the median of that. So that's going to break it up into what percentages of data? 25 and 25, right? So you have the lower 50%, you've just broken it up into 25% and 25% of the data by the first quartile. Similarly, the third quartile, then you should take all the upper 50% of the data and you find the median of that. That's the third quartile, breaking it up into 25%, 25%. Make sense? So now rather than the median breaks it up into 2 equal-sized sets, the quartiles break it up into 4 equal-sized sets of data, 25% each. Okay? Then the interquartile range is the difference between the first and third quartiles. So remember the overall range of the data was the max minus the min. So this is a different kind of range, the interquartile range. It's the third quartile minus the first quartile. So what percentage of the data will fall within the interquartile range? What percentage of the data will fall within the interquartile range? Oh, I guess it's a harder question than I thought. She wants 50%. Why 50%?
Between the middle number and the middle number of the third quartile. So anything in between those two, that's 50% of the breakup.
She said 50%. Agree? Yeah, because we're now at 25, 25, 25, 25, right? So the interquartile range is that range in the middle from the upper. So we got, we'll see in the next thing. But yes, 50% of the data falls in the interquartile range. Okay, so here's the 5-number summary. From the min, so you think about this. 25% of the data falls between each one of these pairs of things. So the interquartile range then is this one. It's the Q3 minus Q1. That's going to be 50%. So you got a visual of it? Does it make sense? Okay. Again, now, so this, the 5-number summary, all these numbers are a way of looking at the variability based on the median, whereas all that stuff we did before was the variability based on the mean. Okay, so let's find for this set of data, let's find the median, or the second quartile, the first quartile, the third quartile, the max, the min, and write out the 5-number summary. Okay? So just finding the 5-number summary for this set of data. Work together. Share the load. Don't break up the task with your partner. You don't have to whisper. And find the interquartile range. Okay, any questions? Even if you're arguing by yourself, compare the person next to you. Any questions?
Just minus the base number minus the square.
Damn it. It's so easy to miss in here. Damn it. Happens to all of us. $143. Okay, so I got 5, 23, 30.5, 36.5, and 66. Agree? Someone agrees over there? Make sense? So this is this is the min. This is Q1. Q2, which is the same as the median. Q3, max. This is called the 5-number summary. Chopping it up into 25% buckets, 25% of the data in buckets. It did so then it's just the median of the top half. Yeah, so we got 10 data values in the top half, so we just forget about the rest and I'll do the median of those. Yeah, just look at the data, right? So you're going to go, yeah, 5, exactly. You look at those data values from 5 to 30, forget about Q2, forget about it, and just do the median of those. Yep. Other questions? Okay, so how do we find the interquartile range? The interquartile range then? What do we do? Tell me. Or just how you set it up. And the answer is? So that's how wide in terms of number. So there's a range of 13.5 hours. So this is hours per week that people watch TV, okay? Hours per week. So there's a 13.5 hour range or span in the middle of the data set that's half of the data set, right? That's half of from here to here. Is half of our sample. And that the width of that range is 13.5. Okay, so any questions on this? Everyone got it? We good? All right, so then we have these other things called upper and lower limits. These numbers are not, they're new numbers. They're not numbers from the 5-number summary. Okay, so let's write out our 5-number summary here horizontally. Tell me again, what was the min? Q1? Sorry. Was it 30.5? 30.5? Then 36.5 here? And the max was? There's our 5-number summary. These are 2 new numbers, okay? And what these do are they help identify potential outliers in the data set. So what we do is you take the interquartile range, and we found the IQR was what? 13.5. And we're going to take 1.5 of that. 1.5 of that. Who's got, tell me what that is. 21 something? 22? 20.25. Okay? And what we're going to do is we're going to subtract that from Q1 and subtract that from Q2, or add that to Q2 to get these numbers called the lower and upper limit. So what is Q1 23 minus 20.25? Is that 2.75? So 23 minus 20.25, I think it's 2.75. And if it's not, speak up. So where does that fall? That falls here. Less than the min. So that minimum, this tells us whether we have this helps us determine whether we have a lower outlier or not. That minimum 5 is still above that. So that indicates 5 is not an outlier. You see that? What about this now? 20.25 plus Q3. So 20.25 plus 36.25 would be 56.75. Is that right? So what about 66? Outlier or not? That is a potential outlier. So these lower upper limits are kind of like, based on what's happening in the middle, helps us determine if we might have outliers or not. What was the next data less than 66? What was the one before 66? 43. Okay, so 43, not an outlier. It's less than 56.75. But this 66 is outside the upper limit, so that's called a potential outlier. Okay, so now once we have the upper and lower limits, we make what's called a box plot or a box and whiskers plot that's a visual representation of the spread of the data based on the median, based on the 5-number summary and the limits. Okay, so make a scale here. And so we'll just go with 0, 10. So make your scale even. Okay, we've got our scale. So then we're going to put in, so you make a box that shows the interquartile range. So the bottom of that would be here, 23. And then the top of the interquartile range would be 36.5, be about here. And then our median is here. So this forms the box. 50% of the data lies in that box, from 23 to 36.5. And then the line in the box shows the true center of the data, 50%, right? And then now we create what's called the whiskers, and the whiskers go out to the lower and upper limits. Or, okay, so it's the whiskers will go out to either the lower upper limits or the max or the min, whatever makes sense. So in the bottom, it's going to go to, it won't go to the lower limit because our minimum is greater than that. So we're going to use the actual minimum to show that value there. So they do a line. Sorry, so a line like this at 5. Okay, but now for our upper whisker, we're not going to use the max. We're going to use the upper limit because we're going to show that that max is an outlier. So now for the upper limit, we're going to do 56.75. And then we're going to show our outlier here. That thing is our outlier. Okay, so the whiskers, the lines that's sticking out from the box, they don't necessarily show the 25% ranges anymore, right? Because they might, if they're based on the upper and lower limit, they're going to show less, because then you're going to have outliers. So here we use so sometimes you're going to use the min or the max. In this case, it's the min. Sometimes you're going to use the upper or lower limit. In this case, we use the upper limit here. Why? Because the max was outside of the upper limit. If our min would have been below 2.75, then we would have used 2.75 for this. So where the whiskers end depends on if you have outliers or not. If you don't have outliers, the max or the min will be the end of the whisker. If you do have outliers, then the lower or upper limit will be the end of the whisker. Does it make sense? Okay. Anybody have a question? All right, so let's try one more example. Can I erase this? So by writing min and upper limit here, I'm saying in this example. So this could be the min or the lower limit. This could be the max or the upper limit. You have to figure out which one it is. This will always be Q1, Q2, Q3. The box always shows that middle 50% of the data. Okay, so what do they call those, the end? Adjacent values. So the ends of the whiskers, they're calling the adjacent values. The adjacent values are either the max or the min or upper limit, lower limit. Okay, you don't have to copy all this down. We don't have time. Let's do an example. So here's the one that we made. Right here. This is the one that C. That was the one we just made. Yeah. Yeah, like I did. Yeah, always show that. You got to show the outliers. Show the outliers if they're outside the lower or upper limits. Okay, let's do another one. Say it again?
There are several outliers to your policy.
Yeah, but normally there aren't several outliers. So if there's several outliers, then they won't be outliers because they'll be significant to the data set, right? So normally you don't have a lot of outliers just by the nature of what they are. What's that? I need to start again here. Okay. Got to start over, sorry. Oh, and so the quiz is posted on Blackboard, and the next assignment is due Sunday night. The first half of the assignment that's due Sunday night, which is what we're doing in class today, is material on your quiz. So if you want to work on the first half of the homework before Wednesday, that'd be a good idea. It's Chapter 3, Homework 2. And I'm going to do one of those now. I think there's an error in the problem, so that's the one. I think it's number 4. Yeah. So when I did this problem last night, there was an error in they're asking for all these explanations. And in the explanations, the numbers didn't match with the real numbers. So just beware on number 4. I might even just delete it from the set. Okay. But anyway, so they give it, this is a magazine discussed capital spending of telecommunications companies in 2 adjacent countries. The capital spending in thousands of dollars for each of the 27 companies is given below. Okay, so here is this data set for 27 companies on their capital spending in telecommunications in thousands. So for instance, one company right here spent $405,000 on telecommunications. So we're going to use StatCrunch, okay? So it was that first example, it was good that we did it by hand, so we saw what we were doing. But now if we understand what we're doing, we use the technology, right? So there it goes. And we're going to go to Stat, Summary Stats, Columns, Variable 1. And if you look down here, you notice that range, min, max, Q1, Q3 are all in there. And if we want, we can add to that, we could add interquartile range, and so it'll all be done for us. So, median 3358, min 20, max 17,443. Got lower Q1 584, Q3 6069, interquartile range 5458. So all those numbers that we got, the 5-number summary, we can get automatically from the stat crunch. Okay? So we can put those in. But we would have to, let's not go through I'm going to delete this problem, but we'll use it. But I'm not going to go through and enter the answers in. So what I want you to do is, I want you to find the lower and upper limits and create the box and whiskers plot. So find the lower and upper limits and create the box and whisker plot and identify any outliers. Okay? So first of all, let's write down the 5 summary average, 5-number summary. So you do that from least to greatest. So we're going to go 20, 584, then the median, 3358, then Q3, 6069, and then the max, 17,443. So when you write out the 5-number summary, you go from least to greatest. Min, Q1, median, or Q2, Q3, max. So now I want you to find the upper and lower limits and create the box and whiskers plot. Okay, what'd you get for the lower limit? Anybody get the lower limit? Nice and loud. Negative 8,000 something. Okay, doesn't come into play. So our adjacent value on the left here is going to be what? 20. Our min. So this is 20, and this is 584, and this is our median 3358, and this is our 6069. And what did you get for the upper limit? Nice and loud. Did you get it? Oh, 14,000? Something like this. So again, here we use this adjacent value is going to be the min, but this adjacent value ended up being the upper limit. And then how many data values, what data values were above that? You said 14,000 what? 26.5? How many data values fell above that? 1 or 2? There's the 17,000. Is there just that one? Then just the one outlier here, which was the max. Any questions? Does it make sense? Any questions? So we got the box shows 50% of the data. It's from Q1 to Q3. Then the whiskers show, they don't necessarily show 25%. Okay? Because we don't want outliers to be in those whiskers, right? So we want a normal range for the data. That's what the plot is going to show. It's kind of a normal range for the data. We want to identify outliers with that 1.5 rule. 1.5 times IQ below Q1 and above Q3. Any questions? Okay, quiz is posted. The actual quiz I'm going to hand to you Wednesday is posted. Work on it. And then you can work on if you want to, work on the first half of the homework to get ready for the quiz. It's based on this stuff that we did.